Mr. Bond, I've been expecting you. Sorry, wrong audition. Let's try this again. Hey everyone, welcome to my talk about composable architecture in Laravel. We are at Laravel Live Pakistan, which I believe is the first Laravel Live Pakistan, which is fantastic to see. Always good to see the community growing. So, thanks for having me. Honoured to be here. Speaking of me, who am I? So most people know me as just Steve King. I work for a company called Treble, who provide developer tools for APIs. And what we do is give you real-time insights into your APIs. It's pretty fun. I'm all about APIs. I typically give talks at places like this. I also write for PHP Architect. And when I'm not doing that, I'm typically live streaming on YouTube. I enjoy giving back to the community, and I enjoy teaching people what I know. I find it's really helpful. So, what is this talk? This talk is all about composable architecture and how you can take your code base that may be struggling and make it better. So we've all heard of the monolith. Kind of looks like this. Everything's all kind of together. It's all talking to each other. It gets pretty messy. And it does kind of look like a ball cube, which will explain why I look like this whenever I need to add a new feature. It's confusing, it's messy, sometimes it doesn't compute. It's not great. So, is there another way? There could be. So how do we tackle it? Obviously, microservices to the rescue. Everybody loves microservices. Everybody should be doing microservices, right? Isn't that what they tell us? Well, not quite. So, the problem with microservices is that you end up splitting the complexity across hundreds of services. And yes, this is another Star Trek reference. This is the Borg homeworld, basically. And it ends up being more of an orchestration problem. So maybe not microservices, but where does that leave us? There's got to be a solution, right? Surely there's a solution. So maybe we should talk about composable architecture a little bit more. What is it to start with? So instead of splitting your application into lots of services, we split the features into packages, not just sparsy packages. Frake creates amazing packages. The team at Sparsy are great, but we need more than just Sparsy this or Laravel that. We need to split things out into things that make sense for our business. We want to split that functionality away. And it is that simple. So we're going to walk through an example. We've got a Laravel application and it manages IoT devices across the city and it's currently a monolith. Somewhat normal, somewhat expected, exciting. So let's walk through this monolith now and understand how it works and how it's all put together. So all of our logic is in that app namespace. Very normal for a Laravel application. It's always in the app namespace, right? So this is a typical Laravel setup, typical default structure for your application. We've got our routes. That's our web routes, our API routes, our socket routes, our console routes. Anything to do with routing goes in this directory. That's how we know it. It's what works. So what's next? Other than routes, what does our application need? Well, we need to have a database migrations, right? Our factories and our seeders, anything that we need to kind of boot and set up that database itself. That lives in the database directory. Typically, you have your migrations, your seeders, your factories. You might have seeders for different environments, not the point. But then we have our resources, service CSS, JavaScript, and views all live in that resources directory. Whether that's inertia, whether that's Livewire, no matter what you're doing, you will have something within resources. It could be emails. But then we've got our dependencies in our composer.json. That tells our monolithic application that we have got this version of Laravel. We are using this version of PHP. We need these extensions for PHP to work properly, and we want to use these packages. We will also have our npm one if we're using npm. But then we've got our application logic. That is all within that app namespace. We've got HTTP, we've got our models, we've got our providers. This is obviously using the Laravel 11 skeleton, which I absolutely love the trimmed down version, by the way. But obviously here I'm using Livewire. So I've got all of my logic, everything to do with my application within that one app namespace. It gets big, it gets busy, and it starts to get confusing. There is a better way though, right? At the minute, it's all together. It's all in one repository. It's like a mono repo that isn't what we want. And we can agree that microservices aren't going to help us. I think we can all agree that one. So, what can we do? What options are available to us? So let's talk about the composable part of composable architecture. That is probably why we're here and why we're interested in talking about it. We've heard about microservices, we've done monoliths, we know about service-oriented architecture. We can talk about DDD. And microservices won't help, but the idea of splitting our code is a good one. So composable architecture, you're probably already doing it. Kind of. Maybe not strictly, but you're relying on packages to perform certain parts of functionality. You're relying on maybe Sparse's permissions package. Maybe you're relying on some sort of filament dashboard with some filament extensions also installed. So you're already in the right mindset. So we split our features into these maintainable packages. Instead of just saying these packages that we already know about we're going to use, we're going to take our business logic and we're going to split those into packages that we can install. Simple, right? Let's go back to the example. It's an IoT management console for a city. So we're going to break down the features. We've got users and authentication, device registration and catalog, data ingress. We've got some basic things that we know we're going to want to achieve with our application. We want to start breaking these out into packages. So how can we do that? Obviously, we extract code, we write the code, and then in our core application, which is a thing that you'll eventually deploy, you just pull it in. Composer acquire your organization / console-auth. We want to pull in that authentication functionality into our package. Quite simple. We can agree that one. Device registration and catalog, exactly the same. Composer acquire your organization / console-devices. You want to name the packages so that they make sense. And these can be on private repos. They can be however you need to manage them if you don't want them to be public facing. And then finally, we've got our data ingress. So we can composer acquire your organization / console-ingress. And each package is going to contain only the business logic that you need to complete that functionality. And we pull all of that into our main application. So let's look at an example package for a moment. It looks a little bit like a normal PHP package. You're probably very familiar to this if you've ever looked at any package source code before, or if you've ever looked at any open source packages in general. We have a source directory with all of our logic in, we've got a composer file, we've got the works. So we have a root directory here. We're going to define our feature roots within that directory. Whether that's web, whether that's API, console, broadcasting sockets, no matter what it is, keep it similar to what you're used to. Keep the roots in there. You can publish them. Everything's great. Then we've got our featured database migrations, our factories, our seeders, all in the database directory. That's very similar to what we used to within our application code. So keep it consistent. Keep it memorable. Don't try and be overly clever with it because it's not going to get there. Anything to do with the database migrations, factories, or seeders, keep in the database directory. It's simple. And then the same thing with resources. Any CSS, JavaScript, or views that you might need to create for your functionality or for that feature to work, it can be pulled into the resources directory. And your packages can require your main package as a dev dependency. It's a little bit of circular dependency, but it's not terrible. And then we've got our composer JSON file. That's all the dependencies specific to this feature itself. Anything to do with what is required for this feature to be successful. Like I said, it could require your actual main application as a dev dependency. That allows you to rely on binding logic within that core application. Then inside source, we've got our feature logic. Any HTTPs, integrations, any controllers, any middleware. Then we've got models, any database models that you might need, any service providers, and any Livewire components, because I'm a huge Livewire fan. So here we've got a package service provider. This is what we will kind of register within our composer JSON, and we'll tell Laravel when we're installing this about it, and it will auto-register it, and things will start to link up and work. It's how the Laravel package system works, and it's a perfect example for the composable architecture. So it is relatively standard. You can see it's a package service provider class, and it's extending Laravel service provider. We've got our two methods. We've got our boot and we've got our register. When the package boots, what do we want it to do? And what do we want this package to register to the container? So registering container bindings is a huge thing that I like to do in my Laravel applications and our Laravel packages. So within our register function, or register method, should I say, we can just say this app bind, or this app singleton, depending on what you need. Here, what we're going to do is we're going to register a singleton for the console service. That is something that is going to come from my main application that I want to bind into each package. The concrete implementation is a callback that's just going to new up the console service so that package A knows about where it's installed. It's got a broker, and we're just going to make the message contract. Steve, what is this message contract? You're just showing me lines, and why have you called it broker? What is this magic? What is this craziness, right? So you need a way for your features, your functionality to communicate. It's that kind of composable part that needs to talk, and it needs to talk to the core. And RabbitMQ or something similar is absolutely perfect for this. You can use events. You could use dispatchable jobs. You could use anything you like, really. But RabbitMQ is absolutely perfect for this. You have parts of your application listening for these messages, and your components, they aren't bound to any specific functionality. They just know that when something happens, I need to send a message. Whatever's listening to that is outside of the scope of my functionality, outside of the scope of my feature. That is a core functionality. It is not package or feature dependent. So we want to be able to leverage something like RabbitMQ or any sort of communication interface, really. You wouldn't want to use a network interface. You wouldn't want to go HTTP to call your own API, or you wouldn't want to, gRPC. It's not what it's designed for. So if you've got all of these parts of your application that need to talk to each other, RabbitMQ is open source. It's easy, really, really easy to use and set up in Laravel, and it just works. No question about it. So, what's next? What is this solving, right? What does this solve? That's the important question. It solves a lot of things. From a development perspective, you've got features that you can work on in isolation. From a management perspective, you can track progress independently. So let's compare it to a monolith. What does it solve in terms of a monolith? So monoliths, and following that composable architecture, you're going to get a better level of flexibility. You're going to be able to do a lot more. You're not going to be constrained by what's already there. You're not going to potentially break anything. It's going to be more resilient. You're going to have independent packages that are tested in isolation. And then in your core application, you can test that, okay, does this happen in the core when I do this in this feature, which is through a package? Does it talk to each other? We've got a lot more resilient code at that point. What else? Debugging. You debug in isolation. You can go through your package and you can build out what you need. Debug where you need to debug. You don't have to start chasing through several layers of vendor calls to find where this code was called. Composable architecture will give you that. You know it's within this package. You can debug that package in isolation on its own without that core application getting in the way. So how about microservices? What does composable architecture solve compared to what microservices solve? So by default, microservices are designed to be flexible, business focused. Each service is focused on this specific task. And it's great until you get to the point where you're Netflix and you've got so many microservices that your business focus is spread out. Your monolith problem has become a network or an orchestration problem. So by following composable architecture, what you're allowing yourself to do is to build these features and build these composable packages so that they are business focused. They only focus on this aspect of the business. They do everything to do with that. They're designed to be plug and play. Microservices, you've got to start setting up gRPC contracts, protobuf contracts. You've got to start figuring out how they're going to communicate to each other. And yes, you do have that with composable architecture, but as I mentioned, you can use something like RabbitMQ to communicate over that protocol internally, and it just works. And complexity. Microservices are complex. The way that they communicate, the way that they can all work together and worrying about any race conditions, composable architecture eliminates that problem. And a question I get asked a lot is, okay, it sounds great, Steve, composable architecture, fantastic, but would you use it? Honestly, like most things, when it comes to development, it depends. And I know that's a bit of a rubbish answer, but it really depends. What is your use case? What do you need? What problems are you actually facing with your application right now? So, are you a software agency that builds similar software for similar clients. You always know you need an authentication module. You always know you need some level of reporting or auditing. Great. You build similar applications a lot. You build a lot of, I don't know, e-commerce applications, or you build lots of micro stores. You're going to have a lot of similar functionality that you could always pull from that composable package. If you have any experience in open source, you're going to understand the methodology behind it. You're going to understand the package release lifecycle. You're going to understand pulling in dependencies and maintaining dependencies. So composable architecture, it could be perfect. Is it perfect though? It's not perfect for every situation. It's perfect for a few, but your use case and your mileage may vary. Can you neatly pull out each bit of functionality from your application into a neat little package that doesn't rely on anything else? If so, then composable architecture is perfect. Let me tell you the story. So, I work on products. I've worked on products for so many years, SaaS applications. I've been building SaaS apps probably since before there were SaaS apps. And where I am right now at Treble, we've got a core product, which is Treble. And what it does, it monitors and observes your API. You tell us what's going on in your API. We aggregate, we analyze, we tell you what's going on. But then we started releasing these developer tools, right? So we also want to know what's going on with your OpenAPI specification. We want that to work within Treble, but we also want it to be standalone so that people don't feel they have to use Treble. They can use this for free, and it's great. So we've got a dedicated identity service. We can do SSO, we can do OAuth, OpenID Connect, email password, an identity service. Like Auth0, but it's our own. And a lot of our applications have similar functionality. So, core Treble and API insights, you want to be able to log into. Kind of normal, right? So each one wants to be able to talk to the identity service. We want to authenticate all of our users against the identity service so that someone who uses API insights, for example, they don't need a whole new account to log into Treble. Or a user of Treble doesn't need a whole new account to log into API insights. And our core product includes functionality that are in these developer tools. So you can use API insights on its own, and it's fantastic. You can get that instant feedback on your OpenAPI specification. Don't need anything else. But you're using Treble already, so that functionality needs to be in there so that people don't have to go from this app to that app to do the same thing. So composable architecture in this situation, we've got a perfect use case. We release developer tools, sometimes for free, sometimes not. We're a business. And Treble wants to implement that. Well, it wants to take that functionality and also include it. So we've got packages that perform the functionality that we can pull into our core Treble product and interact with in the way that makes sense. And then our products can just implement them in the way that we want them to for you to use them for free. So we've got that perfect use case for composable architecture. But the question is, do you? Now, I can't answer that part for you, but maybe you can. Maybe what I've just spoken to you about how you can approach it, it'll all make sense. So thank you for listening to me ramble on about composable architecture. It's quite a passion of mine. I've been kind of singing this song in the background for a few years. I thought I'd give a talk on it. But I would love some feedback. If you have feedback for this talk, please do let me know. I always like feedback. And you can reach me most places on @JustSteveKing, whether that's Twitter, X, whatever Elon decides to name it next, on GitHub, on Mastodon, I think even Blue Sky, and whatever is out there, just Steve King, you can probably find me. So, again, Laravel Live Pakistan, thank you for having me. It has been absolutely awesome being able to talk to you guys. Have a great day, and I hope you enjoyed the talk. Peace.